Okay, so right here in the image, triangle ABC, A, you see what I'm doing here, I'm pre-highlighting. ABC is congruent to BAE, which is congruent to CDA. All right, triangle ABC is congruent to triangle BAD and triangle CEA. So all these triangles are congruent. All right, so ABC is congruent to triangle BAD, which is congruent to triangle CEA. All right, so all these triangles are the same. All right, what are the measures of the triangle in CEA? All right, so really when we look at ABC, this first one, A is 80 degrees right there. Okay, so the letters might get confusing, but we got to look at each triangle independently. All right, such as in triangle BAD, that means angle B is also 80 degrees. And in this triangle right here, CEA, that angle is also 80 degrees. All right, these triangles have been rotated or translated. So if you can see those transformations that occur, that can help you out a lot. All right, then looking at the next one, let's just go to D right here. In triangle BAD, that's 35 degrees. So that means that in this one right here, that's also 35 degrees because C is the last letter. And then A would be the 35-degree one as well. All right, so the order of the letters matter. All right, A corresponds, the first letter in each one of them corresponds. So A corresponds to B in that triangle, which corresponds to C in that triangle. C corresponds to D, which corresponds to A in that triangle. And then lastly, we have to use the triangle sum theorem. We have 80 plus 35 plus, we'll do angle E because that's what we need to find. The measure of angle E equals 180. All right, we're going to get 115 plus the measure of angle E equals 180. Subtract 115 from both sides. Measure of angle E equals 65 degrees. All right, all of these remaining angles would be 65 degrees as well. So hopefully you can see the rotations and stuff and translations that were occurring between the triangles. Okay, and this one, all right, in the figures, these lines are parallel, all right? All right, and the measure of angle 1 is 101 degrees, all right? Find all other missing angle measures, all right? This is a well-drawn picture. All angles are supplementary, parentheses, add to 180 with angle 1 or are congruent. All right, so like angle 4 is also 101 degrees. All right, they're vertical angles, and you can just tell by looking at it a lot of the time. Down here, angle 5, we're not going to write down two, we'll write it down, vertical angles. All right, angle 5 is also 101 degrees because it's corresponding angles. So I can draw in this picture, angle 1 and angle 4 are vertical angles, angle 1 and angle 5 are corresponding, and then angle 8 is 101 degrees. And we'll write vertical angles VA with angle 5. All right, and notice how they all look the same. There's some kind of rotation or translation to each one of those. All right, then moving forward, angle 2, 79 degrees. Angle 3, 79 degrees. All right, how did I know that? Linear pair with angle 1. All right, they're both have their own independent linear pairs. I'll just draw one of them, angle 1 and angle 2, forming a linear pair. All right, and then just down here as well, 79 degrees, 79 degrees. All right, both of these are independently linear pair LP with angle 5. All right, that's our only choice. They're either congruent or they're supplementary. Any two angles you pick when the lines are parallel and cut by a transversal. All right, and this one right here, all right, both angle 1 and angle 5 are 105 degrees. All right, so I like to write that on my picture. It helps me identify things. All right, so identify a vertical with angle 1 and its measure. Angle 1 is congruent to angle 4 because the vertical angles. So the measure of angle 4 would also be 105 degrees. Okay. Identify a linear pair with angle 5. Boom, right there. Angle 5 and angle 6 form a linear pair. All right, being very thorough. Measure of, we'll say, 105 degrees, and then add angle 6, because angle 5 was 105 degrees, plus angle 6, which we don't know. Ultimately, measure of angle 6 would be 75 degrees. That's how the linear pair works. LPP, linear pair postulate. And why are the lines parallel? Well, it was given, but they're parallel because corresponding angles are congruent. Okay, that's why. Corresponding angles are congruent. All right, when you have any pair of corresponding angles that are congruent, that's going to force these lines to be parallel. Looking at this, all right, what is the measure of angle JMQ? Well, this is hopefully just an easy identification. When we have two lines intersecting like this, vertical angles are formed. All right, and just to be clear, JMQ means you start at J, you go to M, you end at Q. That's how we read angles. So boom, that's 127 degrees right there. Okay, identifying linear pairs. All right, just to be clear how this picture is working, we have angle A, angle B, angle C, angle D. All right, so two linear pairs would be angle A and angle B. That's a linear pair. And then another linear pair going on right here is angle D and angle C. All right, those would be two linear pairs. And I could really even write A plus B equals 180 degrees. I'll keep the notation incredibly simple. D plus C equals 180 degrees. All right, because linear pairs are supplementary. Identify a transformation that would map CBA. So CBA onto EBD, which would be EBD. Okay, you could say a 180 degree rotation around point B, or you could say a reflection over angle bisector of angle ABE. If we bisected this angle over here, continue that line. So you can do a 180-degree spin, or you can flip it over the angle bisectors. And that's just another way to verify that vertical angles are in fact congruent. All right. So, and then looking at this is a good problem right here. This is a parallelogram. So what I'm going to do right here, just to emphasize things, all right, just focusing on these red lines, all right, I just formed parallel lines cut by a transversal. It's a parallelogram, but we have all these angle relationships here, all right? So really you just got to find one, and then everything should really quickly fall into line. All right, like how this angle, oops, how this angle is 107 degrees. All right, there's a bunch of ways to think about it. That's a corresponding angles, which is 170 degrees or 107 degrees. And then we got, boom, that would be 73 degrees because we have a linear pair going on right here. All right, so I just happened to find angle 3 first, which would be 73 degrees. But I could do the same thing. It's a parallelogram. And what we're gonna learn, and we can practice very much in depth, is that opposite angles congruent. So angle 1 would also be 73 degrees. But we can also say, that's how I found angle 3, consecutive angles supplementary. And this is just a fact we're going to continue to practice throughout the school year. All right, so that's 73 degrees as well. This is 107. All right, opposite angles congruent, consecutive angles supplementary.